Assalamu alaikum dear students. Today we are going to discuss another topic of this unit, that is functions. Now let's consider two sets. Set A equals to 1, 2, 3 and set B equals to 4, 5. Then we know that A cross B is set 1, 4, 2, 4, 3, 4, 1, 5, 2, 5 and 3, 5. That is, this A cross B means Cartesian product of these two sets contains these 6 elements. Now if we consider any subset of this A cross B, that is, let R1 be one of the subset of A cross B. Here R1 is 1, 4, 2, 5, because 1, 4 is element of A cross B and 2, 5 is also element of A cross B. That is why R1 is subset of A cross B. Similarly, R2 is 1, 4, 2, 4, 1, 5, 3, 5, another subset, and R3 equals to 1, 4, 2, 4 and 3, 5. So these are three different subsets of this A cross B. When these are the subsets, this means that these three are also the relations, because relation simply is subset of A cross B. Now when here domain of this R1 means domain of first relation is simply set of first entries. Here set of first entries is 1, 2, that is domain equals to 1, 2, which implies that domain is subset of A, not equals to, but this, it's a proper set. This set or the domain set is not equals to the given set or the first set. In R2, domain equals to 1, 2, 3. Actually the set of first entries is 1, 2, 1, 3. So simply we can write 1, 2, 3, which equals to set A, means first set, and domain of R3 is simply 1, 2, 3, that is set A. So clearly here this R1 relation first, it is different from these two, because the domain of this very function, this very relation is proper subset of A. Now we will consider those relations where the domain equals to the first set, this whole set. Here we have two such relations. First one is R2 and second is R3. The domain of R2 is 1, 2, 3. Domain of R3 is 1, 2, 3 means set A. But where is the difference between R2 and R3? Here in R2 we have 4 elements. 1, 4 here. 1, 4, 2, 4, 1, 5, 3, 5. Is there any difference between these two elements? Yes, there is a difference. We have two elements, 1, 4 and 1, 5. 1, 4 and 1, 5 are two elements. Usually two different elements with same first entry. Here 1, 4 and 1, 5. This means that under this relation, 1 is related with 4 as well as 1 is related with 5 also. But in R3, there does not exist any two ordered pair having same first entry. So this means that there does not exist any ordered pair in R3. There does not exist any ordered pair having same first entry. But in R2 there exists at least two ordered pairs having same first entry. Domain of R2 is A, while as domain of R3 is also A. Now here this difference is that in R3 there does not exist any two ordered pairs having same first entry. This difference changes the structure of this very relation, and we usually call this R3 as this special relation as a function. So what is simply the function? So function is simply a special relation, and in function domain equals to first set, like in R3 domain equals to set A, and there does not exist any two ordered pair having same first entries. So in R3 there does not exist any two ordered pair having same first entry. Now relation is simply denoted by R from A to B. Now this function or this spatial relation is usually denoted by F in order to differentiate between relation and function. From this we conclude that every function is relation, because here R3 is the function. Function means domain, that very relation where domain equals to first set. There does not exist any two ordered pair having same first entry. In R2 it is simply a relation, but it is not a function. So every function is relation, but converse is not true. This means that every relation need not to be a function. So we denote this spatial relation, that is R3, by F. We can have the visual representation of these two relations, R3 and R2. In R3 we have 1 4 2 4 and 3 5, set A and set B, like this. This is R3. And R2 is, in R2 we have 1 to 4, 1 goes with 5 because we have 1 5, 2 4 and 3 5. So this means that in R2 we have 4 elements shown in this very picture. When we say that relation is a function, because we have these two relations, one is function, one is not. When we say that the relation is a function, relation is function when domain equals to set of first entries. Here domain of both these two relations is first set. So this means that when domain equals to first set and no two element or the elements of domain are related with two or more than two elements of B. That is, no element or the elements of first set are related with two or more than two elements of B. Like if we consider R2 here, one is the element of first set, means set A. It is related with 4, it is related with 5. So this means that we have the element which is related with two or more than two elements of the second set. But in R3 there one is related with 4. So this means that one is related with only one element of, means unique element of B. 2 is related with the unique element of B, and 3 is related with 5, that is unique element of B. So when this uniqueness is preserved, we say that the given relation is the function. So in general we can say that every relation is the function, but every when relation implies function, so when these two things happen, as domain equals to first set and elements, no element of this first set is related with two or more than two elements, then we say that the given relation is the function. But in general, relation does not imply as the function is, but function is always a relation, So let us define what is the function. Let A and B be two non-empty sets, then the function, it is the function which is denoted by F from A to B. It is a rule which associates every element of A, here every is here highlighted, every element of A with the unique element of B. Unique is also highlighted. I highlight this unique here. Every element, what is every element? Every element means domain of this. When every element is related means domain is whole set A, and unique element of B means no two ordered pairs have same first entries, means every element of A is related with the unique element of B, means no two elements of A have the same first entries. Like in R2 here, 1 4 and 1 5. So this means that uniqueness is here affected, because one is related with two elements, that is element 4 and element 5. So if we have a function f from A to B, then clearly f is a subset of a cross b, because every function is firstly a relation. Here domain of f means domain of this very function is set of first entries, means f domain of f is a. When it is a subset of a cross b, means it contains the ordered pair. Let f this f contains x ordered pair y, that is xy belongs to this f. Means when xy belongs to this very f, this very relation which is actually the function, this means that x is related to y under this f, and x belongs to a, y belongs to b. Like x is related with y under this f as represented in this very fig. Here y is called the image of x, because y is image of x, means x is related with y under this relation f, under this function f, and x is called as the pre-image of y. When x is related with y under f, we simply write f of x equals to y. F of x equals to y means value of the function at x is y. This means x is related to y, or x ordered pair y belongs to f. Set of all images means set of second entries. Set of second entries, it is called as the image set. It is called the image set, and this image set is simply called as the range set of f. So range of f equals to set of all images of f. So clearly range equals to, it is it is a subset of simply set b, subset of b, where b is called as the codomain of f. Codomain of f, as in functions we define b to be the codomain, and range is subset of codomain. Similarly in functions, range is subset of b, where b is called as the codomain. Inshallah, in tomorrow's video lecture we will discuss the few more examples in order to clear this very concept. So thank you.